Take a wolf and a dog, put them in the same room as a human, give them the same problem to solve, a container with food inside that they can't open themselves. The wolf figures it out alone, keeps trying, keeps adjusting, gets it eventually. The dog turns around and looks at you, just looks at you, like you're supposed to do something about it. That moment right there, that single behavioral difference, that's 15,000 years of evolution sitting in one room, and it tells you almost everything about what actually changed between these two animals. Because it wasn't just appearance, it wasn't just size or coat or temperament. Something shifted inside the brain itself, in how information gets processed, what gets prioritized, what the animal is even trying to do when it looks at the world. And some of what changed is genuinely strange when you sit with it. Dogs didn't get domesticated from the gray wolves we have today. Both dogs and modern gray wolves share a common ancestor that's now extinct. So it's not quite accurate to say dogs are tamed wolves. They're more like cousins who went down very different roads from a shared starting point. The split happened somewhere between 15,000 and 40,000 years ago. Researchers still argue about the exact number. What most agree on is the general mechanism. A population of wolves, probably in Eurasia somewhere, started hanging around human settlements, scavenging waste, staying close enough to benefit from proximity without getting killed for it. The ones that could tolerate human presence survived and reproduced. The ones that couldn't fled or got eliminated. Over generations, that selection pressure created animals increasingly comfortable around humans, and comfort around humans turned out to be a doorway to something much more fundamental changing in the brain. The first thing that had to change wasn't intelligence or social ability. It was the stress response. Wolves have a hair-trigger fear system. It's appropriate. In the wild, hesitating when something large and unpredictable appears is how you die. The amygdala response is fast, strong, and hard to override. That's not a flaw. That's the wolf working correctly. Early proto-dogs that stayed near humans had to dampen that. A wolf-level fear response around humans means fleeing every time someone moved suddenly, which means no food, which means no survival. The animals that passed on their genes were the ones whose stress systems were slightly less reactive, a bit more tolerant, a bit more able to assess before fleeing. Dmitry Belyayev demonstrated what this selection pressure actually produces, his famous silver fox experiment starting in 1959. He selectively bred foxes purely for tameness, nothing else. Within a surprisingly small number of generations, he got foxes that actively sought human contact, had floppy ears, spotted coats, curled tails. The same physical traits that separate dogs from wolves appeared without anyone selecting for them, just as a byproduct of selecting for reduced fear. The body follows the brain, change the stress response, and everything else starts shifting too. That physical stuff, the floppy ears, the shortened snout, the size variation, that's interesting. But what Belyayev's experiment also showed, which gets talked about less, is what happened to the brain's social processing. That's where it gets genuinely strange. There's a test researchers use called the object choice task. You hide food under one of two containers and point to the correct one. Then you measure whether the animal follows the point. Wolves, even wolves raised by humans from birth, socialized extensively, mostly fail this test. They don't reliably follow pointing gestures. They look at your hand, not where it's indicating. Dogs pass it. Puppies pass it on their first attempt with no training, no conditioning, no prior exposure. 8-week-old puppies who've had minimal human contact will follow a pointing gesture to find hidden food. This is not a learned skill. It's not something dogs figured out through exposure. It's baked in at the genetic level, a capacity for reading human communicative intent that appeared as a direct result of domestication. Dogs developed the ability to understand what humans are trying to tell them, which is a form of social cognition that's rare even among primates. Chimpanzees, our closest genetic relatives, animals with complex social structures and documented tool use, largely fail the pointing task too. Dogs, who share no common ancestor with us anywhere near recent, pass it instinctively. That's the thing domestication actually built, not a tamer wolf, something with a fundamentally different social brain. Here's the other side of it, because it's not a clean story of dogs being better. Wolves are better problem solvers, specifically independent problem solvers. When faced with a task that requires figuring something out without assistance, wolves outperform dogs consistently. They persist longer, try more approaches, don't give up, and look for help. Dogs default to checking in with humans almost immediately when something is difficult. That's the container experiment from the beginning. The dog isn't being lazy or dim. It's doing exactly what its brain was shaped to do. Humans are a resource. When problems arise, accessing the resource is the efficient solution. The wolf's brain never learned to offload that way, so it didn't lose the independent persistence. The dog traded some of that cognitive self-reliance for the ability to collaborate, to read human signals, to work with rather than around people. Which one is smarter depends entirely on what problem you're trying to solve and whether there's a human in the room. What changed physically inside the skull? The dog brain is smaller than the wolf brain relative to body size, roughly 30% smaller in some measurements. That initially sounds like a downgrade. What actually happened is more specific. The regions associated with fear processing and territorial aggression reduced. The regions associated with social behavior and reading emotional signals didn't shrink the same way, and in some cases show different patterns of activation compared to wolves. There's also something that happened to the oxytocin system. Oxytocin is involved in social bonding. It's the same neurochemical active in human parent-infant bonding. When dogs make eye contact with their owners, oxytocin levels rise in both the dog and the human. That mutual hormonal response to eye contact across species doesn't happen with wolves and humans. It's a biological bonding mechanism that developed specifically through domestication. Your dog looking into your eyes is triggering a bonding response in both of you simultaneously. That's not metaphor. That's measurable chemistry. And wolves just don't do that with humans. What this means for how you see your dog. Your dog isn't a simplified wolf. It's not a wolf that got tamed down and lost things. It's an animal whose brain got restructured around a completely different set of priorities. Ones that center on reading you, working with you, staying connected to you as the primary strategy for navigating the world. The wolf's primary strategy is self-reliance. The dog's primary strategy is you. That's why the dog turns around when the container is stuck. It's not confused. It's executing the most efficient solution its brain knows. Access the human. It's the same reason your dog watches your face constantly, why it knows your routines before you've consciously signaled them, why it responds to your mood before you've said a word. 15,000 years didn't produce a tamer predator. It produced an animal specifically shaped to live inside the human world and make sense of it through us. That's a weirder and more specific thing than people usually give it credit for. The wolf is not the dog's past self. The dog is not a failed wolf. They're two different answers to two different questions. One shaped entirely by wilderness, one shaped entirely by proximity to us. And the fact that proximity alone, over enough time, can reshape a brain that completely change what it fears, what it seeks, what neurochemicals fire when it looks at another species. Drop in the comments. Does your dog do the check-in thing when it's stuck on something, or does it problem solve on its own? I want to know how much of this people are actually seeing in their own dogs.